some trig equations today. So it obviously has an equal sign, so it's an equation. It's got trig stuff in it, so it's trig equations. So what I can do is we're going to use all of our tools. So for this one, I can see that I can factor it, right? Cosine I can factor out. It's a GCF. So treat this just like any old algebraic equation. So I can take out a cosine. So I have cosine, and then I have 2 cosine minus 1. So all I did was factor it. L equals 0. And now if I have two things being multiplied that equal 0, I can solve them separately, right? So either cosine equals 0 or 2 cosine minus 1 equals 0. And I can continue solving this. So 2 cosine equals 1 and cosine equals 1/2. So all I'm going to do now is I'm going to ask myself, okay, where is the cosine value equal to 0? So if I look at my unit circle, there are 2 places that my cosine is equal to 0, and they are pi over 2 and 3 pi over 2. So there are 2 places that cosine equals 0. There are 2 places on the unit circle that cosine equals 1/2, and that is pi over 3 and 5 pi over 3. So if I were asking for solutions, and I wanted to limit my solutions, so there's 2 ways we can ask this question. We can either give you a range and say, I want all x values between 2 pi and 0. So I don't want to go around the circle multiple times. So if that were the question, I would have these 4 answers and I'd be done. If, however, we ask you for all solutions, that means I can keep going around the circle again and again and again. So for each one of them, you have to list them separately. So I'm going to do pi over 2 plus 2 pi k, right? Because pi over 2 is my first value, but if I add an entire rotation of 2 pi, I get 2, I can add 2 pi k. And I have to do that for all of them. So 3 pi over 2 plus 2 pi k.
You wrote 3.
Oh, thank you.
No, you wrote 3 on the bottom.
Oh, 3 pi over 2. That's right. Sorry. Pi over 3 plus 2 pi k, and 5 pi over 3 plus 2 pi k, where k is any real number. K is any real number. Okay, so if we ask for all solutions, just make sure you tack on that 2 pi k. All right, so let's look at a second.